We are going to solve the 2002 AP Calculus ABFRQ response question. Question number 2. The rate at which people enter amusement park on a given day is modeled by the function e defined by e of t equals this function over here. So this is the rate of people entering the amusement park. So rate entering. The rate at which people leave the same amusement park on the same day is modeled by L, defined by L of t equals this function, so the rate leaving. Both the ET and LT are measured people per hour, and time t is measured in hours after midnight. These functions are valid for 9 is less than or equal to t, which is less than or equal to 23, the hours during which the park is open at time t equals 9. There are no people in the park. Okay, that's good. So it means that there's 0 at time 0. How many people have entered the park by 5 p.m., which is t equals 17? Round your answer to the nearest whole number. So for part A, if you want to know how many people there are, you have the rate. If you integrate it, you can figure out how many people there are. So you'd start with the lower boundary, which is 9, because that's the time the park opens. 17 is what you're measuring. And now you would put in e of t dt. And you'd use a calculator to solve this, and you would get about 6,004.270. But you can't have a quarter of a person or 0.27 person, 0.270 person. So there are 6,004 people who have entered by 5 p.m. Now remember, some of those people leave because that's why that rate function's up there. Okay, part B. The price of admission to the park is $15 until 5 o'clock. That's cheap. And after 5 o'clock, the price of admission to the park is $11. How many dollars are collected from admissions to the park on a given day? Round your answer to the nearest whole number. Okay. So we have two different dollar amounts being collected. $15 during prime time, which would be the 9 to 17, e of t dt, plus $11 because it's now non-prime time, not as many people are going to come, so they want to entice them. So it'd be 17 to the park's closing, which is 23, e of t dt. Okay, so we know this is 15 times the 6,004, plus we know this is $11, but now we need to figure out how many people, so use your calculator. When I did it, I got 1,271. Actually, it was a little bit more, but you had to round down. So now when you do this, I got $90,060. Should put the dollar symbol. Plus, this was 13,981, which made a grand total for $104,041 collected. I don't need that part because it's already in dollars. So let me erase that. So I can put dollars collected. Okay, part C. Let h of t equal the integral from 9 to t, e of x minus L of x, d of x for 9 is less than or equal to t, which is less than or equal to 23. The value of h of 17 to the nearest whole number is 3,725. Okay, that's good. They did that for us. Find the value of h prime of 17. Explain the meaning of h of 17 and h prime of 17 in the context of the amusement park. Okay, so if you want to solve h of 17, that would be the integral 9 to 17 e of x minus L of x dx, which would be the 3,725. So it means 3,725 people are in the park at 5 p.m. Now, if we want to find h prime of 17, it means we're going to take the derivative of this guy, but the derivative of this is just the rates, e of 17 minus L of 17, which equals roughly negative 380. So negative 380, what does that mean in real life? Well, this is about the rate. So it means there are, or the rate is, okay, give me 1 second. So what does that negative 380 mean? It means that the number of people is decreasing at a rate of 380 people per hour at 5 p.m. That's what that negative 380 means. You can't put negative 380 in there because you're already saying decreasing, and then that would make it increasing. Now, part D says, at what time for 9 is less than or equal to t, which is less than or equal to 23, does the model predict that the number of people in the amusement park is a maximum? Okay, so that's not that hard of a question. So if you want to find where the max is, that's where the slope changes from positive to negative or negative to positive, but it has to equal 0. So what we're going to do over here is we're going to do e of x, or e of t, minus L of t equals 0. And now we're going to solve. We're going to use our calculator, and it's going to give us a bunch of numbers. So the first number I got was 15.795. That was in the domain. So now what I recommend is you graph this and you check from the left and you check from the right. And when you actually check this, it's positive, then negative. So therefore it is a max, but you might want to say h is less, or whatever, you might want to say when h is less than 17, it's positive. So let me write that down. H is less than 17. It is greater than 0. Then let me just erase that. Okay, so I got t is approximately 15.795 hours. That's the first point that was in my domain. I got other points. I got 0, but that doesn't make any sense. And then I got 46, but that also doesn't make any sense. So now when you check on a graph, it's actually positive, then negative. So this is a max. So I would say like maybe h prime less than 17 is greater than 0, and h prime greater than 17 is less than 0, therefore a max. Okay, I hope this video helped.